All right. So, yes, ChakraCore. I work at Microsoft on Chakra and TypeScript, and I work on TC39. I do a whole bunch of JavaScript stuff. I pretty much live and breathe JavaScript all day, every day. Today I'm here to talk to you about Node and ChakraCore, specifically about that intersection. So let's get into it. The first thing I want to start with is a little bit of historical record. A long time ago, in a galaxy far, far away, and by that I mean less than a year ago and on GitHub, ChakraCore went open source. So how many people are actually hearing about ChakraCore for the first time today? Quite a few of you. OK, good. I've prepared for that. So ChakraCore is the core JavaScript engine that powers Microsoft Edge and the Universal Windows Platform and some other Windows Platform components. So when you're looking at this chart, the purple stuff, that's all inbox in ChakraCore. The gray stuff, that's not included, but you don't want it anyway. So what do you get with ChakraCore? Well, there's these JSRT or JavaScript runtime hosting APIs. These let you embed ChakraCore pretty trivially in a number of different environments. They're pretty simple C APIs. You can find documentation for them on our GitHub site. It's built for the web, so perf is critical. It's got partial and concurrent GC time-bound collections. It's got a tiered JIT. It executes code super fast. And it has a diagnostics API, because it turns out JavaScript isn't so fun if you can't debug it from time to time. And it doesn't include any of the sort of Windows-specific components. So it's just the core part of the Chakra engine. So ChakraCore went open source earlier this year. We've got dozens of pull requests, contributions from the community. It's been just tons of fun working out there with everyone. And if you haven't checked out our GitHub site, please do. We've got PRs, like if you want to be a runtime dev, we've got PRs labeled for your first time if you want to get in. So happy to have you help out. File bugs, we've had a bunch of issues filed. It's very helpful for us to see that. Yeah, ChakraCore, open source, JavaScript engine. But we didn't stop there. Open source is certainly very critical for working in the JavaScript space. We all love open source. But being Windows only was kind of a downer, right? Like, I see a lot of Macs out there. So we definitely needed to go cross-platform if we really wanted to have the best open source experience possible. So that's something that we've been working on. We recently announced that we have support for AMD 64 or x64, 64-bit Linux and Mac OS X. So you can actually run ChakraCore on these platforms today. Now, it's just the interpreter right now. There's some more work to do to make the JIT work on different platforms and the high-performance GC bits. But that's something that we're working on right now. And hey, we're open source, so go to our GitHub site. You can see the branch for all this cross-platform stuff. And you can watch it unfold and maybe even help out if you want. So while we're doing all of this open sourcing and cross-platform stuff, Node is becoming super popular inside of Microsoft. We probably have millions of lines of Node code at this point. And Node is pretty much everywhere with a few notable exceptions. So Node looks like this today. You can support various platforms, x86, x64 are common ones, ARM v7, pretty important for IoT. But there's one that's missing that's kind of near and dear to my heart, which is the ARM thumb2 instruction set. And this is what's used for the Windows IoT Core SKU, or the Windows IoT Core platform, which runs on IoT devices. And it uses the thumb2 instruction set. So if we get out our thinking jugs, I don't have the audio, sadly. It helps a lot. But ChakraCore runs everywhere Windows runs. It's part of the Windows platform, so it runs on the thumb2 instruction set. We've done all that work to make all of the JIT and stuff work on thumb2. And ChakraCore and Node both kind of run JavaScript, so it seems like there's some kind of opportunity here, and indeed there is. We called it NodeChakraCore, And it's basically a way to take Node and use ChakraCore as the JavaScript engine. And almost immediately, we got the benefits of Node that we all know and love. And we had the benefits of ChakraCore, where we could actually run it on these Windows platforms that weren't supported by mainline Node. So it works kind of like this. You've got these, you've got Node.js, which as far as it's concerned is always talking to V8. And we built a shim that just translates those V8 calls into JSRT calls, those APIs that I mentioned for embedding ChakraCore earlier. Those just get translated to the V8 calls, get translated to JSRT calls, and ChakraCore runs all of the JavaScript. And it turns out that this actually works really well. So we were wanting to progress further on this, and we needed some kind of principles to guide our work. And I think one of the most important ones is we want to help grow the Node ecosystem, because we know that the more people are involved, the more diverse sets of people and scenarios and everything that people try to solve, the better this community gets and the more awesome stuff gets done. So growing the Node ecosystem, bringing it to more devices, more scenarios, more robots, whatever, like that's all good. We can do more of that. Obviously, we want to bring fresh ideas. You know, same old is kind of boring. And another, really critical piece is the Node ecosystem has to just work. If we had this Node-ChakraCore thing that didn't run anything in NPM, you couldn't really even call it Node, right? Like, what is that? Nothing. It's nothing. The Node ecosystem has to just work. And through it all, we have to be open and transparent. We can't come to this awesome open community and just do stuff in the dark and hope it, works out. That's not the way to do it. We have to be open and transparent. And so all of this stuff is happening on GitHub. You can watch it all unfold. You can get involved. You can help us with, direction, next steps, code, whatever. So we had this thing. It works great. We submitted it as a PR to Nodemaster, and that kicked off a pretty big discussion. I don't have the link here, but you can find it with your favorite search engine. Kicked off a pretty big discussion about what the future of Node looks like. Is it something that should Node be VM agnostic? Should other JavaScript engines come into play? If so, how do we do that? Those are a lot of tough questions, and actually we don't know all of the answers to them. So the PR was ultimately closed, and we moved this work into a separate repository under the Node Foundation. The link is there. And this is where you can find all of these Node-ChakraCore bits. You can download the source and build it and all of that. We keep it up to date with the latest stuff from Node and ChakraCore, and we merge it all together there. And we're working with the community and stakeholders to figure out kind of what the best path forward is for VM agnosticism, or multi-VM for Node. So let's take a look at what that is and why you might care. So we really need to grow the ecosystem and keep the ecosystem happy. By that I mean, hey, JavaScript engines, there are different JavaScript engines that are tuned for different workloads. And like I mentioned before, if you can take advantage of a JavaScript engine's specific implementation for maybe a particular platform or service, or maybe it's built for supercomputers or something, maybe that should be a part of Node. I think it should. Spider Node is something that people might be interested in, Mozilla's JavaScript engine. Samsung has a JavaScript platform for IoT. Maybe that could become a node. But just in general, different JavaScript engines are better at different things because they make different trade-offs, and Node should be able to take advantage of those trade-offs. The other aspect is keeping the ecosystem happy. In that I mean, if Node owns this kind of abstraction layer that sits between Node and JavaScript engines, and Node says, hey, you implement this thing and you get to play in this Node ecosystem, that means that Node can be very intentional about breaking changes and the evolution of this thing so that we can do what's best for the community, make sure there are no breaking changes, no, nothing that is going to stand in the way of compatibility or anything like that. And we can involve this interface in a very intentional and deliberate way. So I wish I could report that it's a panacea, everything works, job's done, go use Node-ChakraCore. You should, but just be aware of a couple things. First, while 90% of NPM modules, including all of their dependencies, have no native code in them whatsoever, those all work great. JavaScript is great for multi-platform interoperability. Some modules, roughly 10% if you consider their entire module graph, include some kind of native code. And so some of these modules are using NaN, a native abstraction module. And those ones, for the most part, just work fine, because we did the work to make sure NaN worked on top of Node-ChakraCore. But some modules, they just kind of like include v8.h and then go and reach into the guts of the JavaScript engine and do some crazy stuff. And those are important things, important scenarios that we need to support, but we don't yet have that working. So in order to address this, we need to think about what a VM-agnostic native module API might look like. And that's something that we're advancing as part of the VM-agnostic working group, or VM neutral. Another interesting thing is performance. So if you look at performance on the web, ChakraCore is phenomenal. According to Octane's benchmark, it's the fastest or among the fastest. And Apple's Jetstream benchmark, likewise, really fast. But if you look at Node code, it's kind of interesting. The kind of code that you write in Node is actually different than what you write for the browser. And that shows up in performance. We haven't been running Node code before since we started back in like 2009. And so when we first started running Node code, we realized, hey, there's some patterns that Node people do that we just haven't optimized for yet. And so this green bar on the Acme Air chart on the left, that's where we were in April. And I just ran the benchmark before I came here, so October is that next one, and the gray is Node 6.8. So we have some work to do for performance. But I think for most scenarios, you're actually not going to really notice it. So VM neutrality, I think, is going to be a pretty interesting avenue to pursue as we go forward. Another thing that I mentioned is, in terms of our principles, are bringing new things to the table, new ways of doing things. And I think one of the pain points that Node developers have historically faced, at least for me, is debugging. I'm the kind of guy who does console.log debugging pretty much exclusively. Who else? Console.log? Only? Yeah. Right, exactly. But I think we can actually do better than console.log. I think actually some tools that are out there today are better, but what I want to show you is something I think is really special. And that's called time travel debugging. Time travel debugging is all about wondering what it would be like if you could step forward or step backward in your program. Oftentimes when you're debugging, you get to your breakpoint and you realize, wait, I'm already hosed, and now I have to restart and try to drive my app back to where I left off or where the bug actually happened. And it's just not a very interactive experience. Like browsers have back buttons, right? Debuggers should have them too. And the other interesting thing that time travel debugging helps out with is it lets you debug maybe a production service or a test server or something after it's already crashed. In fact, you can trigger a trace programmatically in your program. You can say, OK, I've clearly walked myself into a really bad place, take a trace, and what you can do with that trace file is just debug it later as if you were running the program. So right now you're skeptical, but I can show you. All right, so good. We've got our everything there. OK, so I'm just going to run this. Oops, wrong one. Hold on one sec. So I've got a node binary compiled here with time travel debugging, and I'm passing this TT-record option. And that's just telling it to turn on time travel debugging. And I give it this TT-log directory, which is the directory I want to dump all of this time travel debugging information to. And then, oops, app.js. I'm just giving it my app. And OK, now it's running. And I can come over to the browser here, and we can see this beautiful, beautiful application that I've built. It's the Holy Grail layout. I think it's the latest or something. So it's just a file explorer, right? You can click on things and see content and all of that fun stuff. But let's say I just want to introduce a bug here. So here's my directory of files. I'm going to move hello.js to hello.fail.js. And now I'm going to go back to my application. And I'm going to click hello.js, and nothing happens. Eventually, all of my text disappears. And if I go look at the console, it crashed out. OK, so I need to debug this somehow. And maybe I'm not familiar with the code base all that well. I don't really know where this might be. Take a gander at this timestamp here. It ends in 1464. We'll be seeing that later. So because I enabled time travel debugging, I have this trace file. I can go into VS Code, the insider version of VS Code, if you want to play with it. It has support for time travel debugging in it. So if you're going to want to use these bits, if you're going to want to use time travel debugging, you got to use this latest version of VS Code. And so what I'm going to do is misclick. And I'm going to use this ttdebug launch configuration. And all that's doing basically is pointing Node at this at the trace file so that it can replay everything that happened. And time travel debugging knows, hey, I want to probably stop at a breakpoint, so it stops at a breakpoint. And so here I'm actually stopped at this breakpoint. And keep in mind, this is all running with all of my past stuff that I was clicking previously. And I can do all the normal debugging things like inspect locals and all of that, set breakpoints, whatever. We see data is undefined. You probably can't read it. It's tiny. So data is undefined, and we're calling toString on it, which is bad. So here we have our normal sort of debugging affordances. We can step forward, into, and out of. But we have this nifty little button here, which is step back. And we can actually use this to just step all the way back to the source of the bug, hopefully. So I guess I'll show here. If you can't read it, take my word for it. That's the same timestamp that we logged on the console a few minutes ago. But that's not where the bug is, so you can just keep stepping back. Here's our routine that's supposed to be figuring out whether we got a valid file out of read file. So clearly this is the thing that's not doing the right thing. So we can step into it. Notice I'm debugging TypeScript code, by the way. That's one of the things that we got working recently is source maps. So anyway, we can keep stepping forward. So we set error info to data invalid. That seems good. And then we set it to null, which definitely seems bad. So the problem here is we just forgot a break. I think this poor coding style might be partially to blame for that. So we can just save this file and run it again, and off we go. So we just debugged something that we ran previously. It could have been something that ran on a production server, maybe. But we can debug it as if we were actually just sitting there in front of the program running, and it's all happening like it, happening like it did in the past. So that's time travel debugging, stepping forward and backwards. I think it'll actually make debugging a lot easier, because a lot of times you really do need to jump around to figure out where how you went wrong. So you could try out time travel debugging right now. This link will take you to where you can just download the bits and try it out. You can also get binaries for Node-ChakraCore on Linux. That's at this link here. You can also build it yourself. It's pretty straightforward. And if you're interested in hosting ChakraCore in an application, like maybe you have a game and you want to script it with JavaScript, you can find those C JSRT APIs that I talked about on our GitHub site. So we have a bunch of work to do on top of, just, keeping on top of the language evolution, all the new stuff on JavaScript, and keeping up on performance and implementing new optimizations and all of that stuff. In terms of cross-platform, we've got to get JIT and high-performance GC enabled on Linux and Mac. That's a work in progress. Like I mentioned, you can follow that on GitHub if you want, and helping out is always cool too. In terms of Node-ChakraCore, we have to support the Chrome debugging protocol. That's what will let you use whatever debugger you want with ChakraCore. That's pretty important. TTD support needs to land in VS Code. Not everyone wants to run insider builds, although I find it's pretty stable. You might as well. And we need to advance those VM-neutral APIs so that we can really get Node into a world where the JavaScript engine underneath can be swapped out for whatever works best for your scenario, and so that module authors can still use native capabilities in a way that works in a VM-neutral world. So with that, I'm done, and thanks, and I'm happy to talk to anyone about anything related to JavaScript. So if you see me, just come up and say hello, and we can chat. Thanks.